Good morning, everybody. Thanks for joining us again. As usual, we're going to give it just a moment for folks to load in, and then we'll get started. So just give us a solid minute or so, and we'll get going then. Okay, we're going to go ahead and get rocking and rolling this morning. Welcome again, everyone, to this edition of the Building Smart Energy Efficient Essentials for Modern Homes series, sponsored by DTE and Consumers Energy. So if y'all are new to this series, we have been conducting a week webinar a week basically since May, with a couple of breaks, and we're going to be going here until November. And basically, what we're doing is talking all about the application of energy efficient design and installation practices in new home construction, basically with the goal of educating builders and policymakers and contractors and building performance professionals on what we can do here in Michigan in order to up our game. And so today we're going to continue our series on the Energy Star single family homes program. And so last week we did a good solid overview of Energy Star as a program, but today's presentation is intended to give a deeper dive into that program so that you understand more specifically what Energy Star is all about. So, first of all, we'll just kind of do a little bit of a recap off of what we discussed last week, just to make sure everybody understands what Energy Star is and what it isn't. And, just teaser, if you weren't here last week, Energy Star is more than just a sticker that you see on appliances or on electronics. Whole buildings, whole homes can be labeled as Energy Star. And so this is sort of part two in that series to talk about what goes into making a Energy Star home compliant with the program's specifications for the building enclosure. Again, if you're brand new to this, I'm Chris McTaggart. I am your presenter today. I'm the president of Building Efficiency Resources. We are a national quality assurance and training provider in the home energy efficiency industry. We work with about 500 certified building performance professionals that operate all around the country. I am based here in Michigan, live in Detroit, and grew up in the great state of Michigan. And I have a deep affinity and love for Michigan as a state, and am very dedicated to seeing the proliferation of higher efficiency home building practices in the state of Michigan. Why? Because it's kind of a win-win for everybody if done right. If we do energy efficiency right, we tend to have more resilient communities, keeping tax dollars and people's money, a little bit more local, because homeowners aren't so stressed with utility bills. Tends to keep people more comfortable in the homes that they live in. So people feel like sticking around and putting down roots. And, I would also say, obviously, there are some environmental benefits of not using so much energy. The excess consumption of energy does lead to pollution in the environment. And so, for all these reasons, it's a win-win to promote energy efficient homes in the United States, but more specifically here in the Great Lakes state of Michigan. So, a little bit of follow up here about Energy Star and what it is as a program and what incentives are available for Energy Star through the DTE and Consumers New Homes programs. So, again, Energy Star is a voluntary program that seeks to be 10 to 20% above energy code. And so, here in the state of Michigan, we are essentially on a version of the 2015 IECC, although it's a little bit weaker than 2015 in reality. But in essence, because we're already on a version of the 2015, we're on version 3.1 of Energy Star, which intends to be 10 to 20% more efficient than a home that was just built to the standard 2015 IECC. So that's what the intention is here. And the program, as it pertains to homes, it's a whole building program. It's more than just, again, appliances. It's more than just lighting, the obvious things, and it's more than just labeled HVAC equipment. In fact, you don't even have to use any Energy Star labeled products in Energy Star homes, just about at all, with a minor exception that we'll talk about in next week's presentation. But so when we talk about Energy Star in this lens, you've heard about it through the EPA. No doubt it's a brand and a label that carries pretty significant consumer awareness. So, but I think the difference is most people, when they think about Energy Star, they think on an individual product basis. Again, in this instance, a whole house can earn the label. There is a separate program for multifamily buildings as well as for manufactured homes. But we're not going to be talking as much about those separate homes-based programs. We're really focused primarily on the single-family homes program. So again, here we are in the continuum of progress with the Energy Star program. We are in the state of Michigan required to meet version 3.1, which is 10% better than the 2012, 2015, 2018 versions of the code, which were pretty similar in performance. And then if you go to the 2021, it drops yet again to version 3.2, but we're not at that point here in Michigan. We still are on 2015, so our state-based version of Energy Star is version 3.1. However, if you're going to meet the tax credit, which is still eligible for homes that are conveyed as of June 30th of next year, basically you have to meet version 3.2. Okay, so again, there is a multifamily new construction program that's separate from single family homes. It really is focused on apartments. Because the consumers and DTE programs are focused on single family homes as well as duplexes and some townhome configurations, our presentation is really going to focus primarily on single family homes. There are incentive programs through DTE and Consumers for multifamily, which can be extended to new construction, but they don't actually require a certification program like Energy Star multifamily new construction. Here in Michigan, if you're seeing people use multifamily new construction, oftentimes it's tied to affordable housing tax credit programs through the low income housing tax credit. Again, beyond the scope of our presentation for today. Energy Star 2 years ago launched a separate sort of sub-brand of the single family program called Next Gen. And that is more of an electrification based form of Energy Star. It builds off of the Energy Star single family spec, but then really is focused on having all electric heating, and water heating and cooking, as well as a few other options. So we will be discussing next gen in a subsequent webinars, but we are not going to go too in depth with it today. Just know that next gen, it's kind of like the single family program, just with a little bit of a spin on it. Okay, so single family homes. When we're talking about the single family program, we're really talking about detached, single family, attached, single family, so like duplex style construction, or we're talking about townhomes. I will say if you get into sort of top to bottom townhomes or front to back type of townhomes, that can get a little bit tricky with qualification under single family. Oftentimes, those configurations will be pushed over into the multifamily new construction program. Okay, so Energy Star Multifamily New Construction is the other program. Again, we're not going super into depth, but everything else that's not single family or duplexes or most townhomes. So basically, apartment buildings are the primary program, but primary target group, that is, rather, for multifamily new construction, somewhat beyond the scope of what we're discussing today. So again, there are multiple versions of Energy Star as a program at any given time. Makes it a little bit tricky, but just think about it. Again, we don't have a national energy code. We do not have a federal energy code that is applied to all buildings uniformly in the United States. Why? Because we have a republic and states get to make decisions like that for what codes they want to implement in their state. Some states have no statewide energy code. Michigan, again, we are on a version of the 2015 IECC. It has some weakening amendments, but nevertheless, about 2 years ago, when the 45L tax credit was tied to Energy Star sunset the version 3 program and basically made version 3.1 the national baseline. So you can't earn the Energy Star label in the United States with anything less than version 3.1 at this point. And you'll notice here there are some states that are either already on version 3.2 of the program or are in a transition phase. Our Great Lakes neighbors over in Illinois are getting pretty close to having version 3.2 become their state-based required program, but they're not quite there yet. So mostly nationally, as you can see, we're on version 3. Some folks move into version 3.2. And then there are a few locations like California, as well as the islands, that have their own regional specifications. So, yep, we're on version 3.1. Typically, you're going to see HERS index scores somewhere in the 55 to 65 range. If you're getting to the point where you want to pursue the tax credit, you should expect that your scores are going to be more in the 45 to 55 range. And that's commensurate with what you would expect for next gen as well. So there are incentives in Michigan through DTE and Consumers Energy that are tied to Energy Star compliance. So if you are in consumers territory, you would want to refer to this chart. And we have sort of called out specifically the Energy Star related incentives on this slide. So you'll notice that if you don't pass Energy Star, that's okay. There's still the ability to get some incentives through consumers, but they are less money than if you go all the way to Energy Star. So let's just say that you're building in a mixed DTE and consumers territory. So let's say that consumers is providing natural gas only. And let's just say that the home scores a 55 on the HERS index. Well, it meets Energy Star. So through consumers, that home would be eligible for $1,400 in incentives through consumers. And then DTE, assuming that DTE is the electric provider, would also be able to contribute some money to the home. So as you can see, the connected and townhouse and duplex Rebates are a little bit less because there's less savings for the utility to be able to claim because of some of the demising walls and whatnot. But there still is an opportunity for that form of housing to participate. Obviously, what's exciting here is that if you get all the way to a 40 or less and you're using a heat pump, you could be getting a $4,000 incentive back from the utility. So that's nothing to sneeze at. So Consumers Energy has had a pilot running this year that has incentivized higher levels of performance for homes that meet above code specifications that are more in the advanced tier. So there is a $5,000 incentive available through Consumers. You have to have already locked in the home to be able to receive that incentive, and it has to be completed by the end of this year. So, but the utility is clearly trying to push folks forward with a more advanced construction option. Again, the 45L tax credit, if you meet version 3.2 or 3.3, which is even a little bit more advanced than version 3.2, then homes will be eligible for a $2,500 tax credit. And then an even bigger incentive for those that meet zero energy ready homes, which we will be discussing more here soon in a further webinar program. So through DTE, there's again an option here for participation with Energy Star incentives. Basically, as long as you're doing a HERS rating and you're getting a 60 or better, you're eligible for participation in the DTE program. But if you get Energy Star, then you get usually a $350 bump. Sort of depends on what the utility is providing. But let's go back to that scenario of the 55 HERS index home that's Energy Star certified with Consumers as the natural gas provider. We would get $1,400 from Consumers for that home. And then if DTE is providing electricity, we would get up to $1,800 through DTE. Now I say up to because it's not quite as straightforward with DTE's incentives. There are different product categories that are eligible for incentives, as well as a deemed savings or rather, modeled savings approach. So it's not quite as straightforward as you get $1,800 off the bat, but nevertheless, this home could be eligible for up to $3,200 in incentives. So it's kind of an exciting thing, not a bad thing for a builder to get $3,200 per home kicked back to them. Okay, so having talked about the incentives that are available, we're going to go ahead and roll into talking more specifically about the program of today, which is building enclosure elements of the Energy Star Homes program. So I would go ahead as far as to say that if you're going to talk about Energy Star Homes, the first and foremost thing that this program is trying to push is better building enclosures. And it does so really through leaning on the code itself, but essentially requiring documented compliance with the code. So the program is not necessarily, Energy Star is not pushing people to have exceptionally over insulated, super insulated building enclosures. That is not necessarily the goal of the program. The goal of the program is to have a quality building enclosure, which is durable, airtight, with proper air sealing and air barriers, as well as properly installed insulation of a sufficient quantity so as to keep people comfortable and keep their bills low. It's actually extremely common sense the way that Energy Star approaches the building enclosure. And I would say it's only gotten more common sense over time. So Energy Star is more than just the building enclosure. It also leans on better HVAC systems, good ventilation, and some common sense air quality measures which we will be discussing in subsequent lessons. But today we're really just going to focus on that thermal enclosure system just to drive home what Energy Star is guaranteeing its consumers who purchase Energy Star homes. So the elements of the program that are related to the building enclosure are really focused on two checklists, the rater design review checklist as well as the rater field checklist. So the design review checklist is intended to be performed by the rater kind of earlier on in the process. So ideally, when a builder approaches them about doing Energy Star on a development, then the rater would receive the plans and specifications. They would do a projected energy model, and they would complete this design review checklist. And one of the elements is under, section number 2, high performance insulation and fenestration. And so the reason why that's an important section is that basically this is what we look to in order to ensure that buildings are designed at a minimum to meet basic requirements of the Energy Star program for better insulation practices. So, if we take a look here, I'm going to use my little cursor. Hopefully you can see that. This section number 2, high performance insulation and fenestration. For all versions except the noted below, which is version 3.2 and 3.3, 100% of the UA of the 2009 IECC. So basically what this is saying is in order to participate in version 3.1, you have to have at least a building enclosure that's as good as the 2009 IECC. Last I checked, this is 2025. So we're talking about an energy code that's about 16 years old now. So it's a basic building enclosure. It's not absolutely prolific, but it is a quality overall, decently insulated building enclosure. That's what's required by Energy Star. If you're going to try to get the tax credit, then you have to either meet version 3.2 or version 3.3. And that gets a little bit more tricky because now that's pointing to more modern energy codes. There is a little bit of a trade-off if you go to version 3.3 because you're allowed to be a little bit less than the building enclosure requirements from the 2024 IECC. Regardless, that's one of the main issues that is being pointed to on the design review standpoint is just, do we have enough insulation throughout the building? And the building UA calculation is inclusive of, all of our insulated assemblies, above grade walls, floors, slabs, ceilings, as well as our fenestration, so windows and doors. So even if, say, you're a little bit light in one area, like your above grade walls, there's the opportunity to make it up in another area, such as your windows. There are some requirements that pertain to window SHGC, but those are really for warmer climates that do not pertain to the state of Michigan. The field checklist is really where we're going to spend most of our time today. It really details all the elements of a high performance thermal enclosure, such as high performance insulation and fenestration, fully aligned air barriers, reduced thermal bridging, and air sealing. So let's go ahead and dive into these. Okay, so again, when we think about a complete thermal enclosure system, Energy Star has purposefully elected to have multiple criteria. It's not just one thing. It's not just put in enough insulation and you're good. No, Energy Star wants us to look at a complete thermal enclosure system. So what that means is, yeah, we need to have enough insulation and pretty good fenestration, and we need to install those properly in the building. But insulation isn't effective if it doesn't have a sealed air barrier system that the insulation is in contact with. That's the way that we have a thermal enclosure that is complete. It's a combination of an air barrier that's sealed at all the seams and penetrations, plus insulation that is in contact with that air barrier. That's what allows us to have what's considered to be a thermal enclosure. Then the program does have elements that talk about reduced thermal bridging. These used to be mandatory elements of the program. They have now, with revision 14, moved to being optional criteria that can be implemented in Energy Star homes. And you can get credit in the energy model if a builder is to implement them. Basically, we're talking about advanced framing practices and or the utilization of some form of continuous insulation system. Again, this used to be a requirement. Now it is an optional element for participation in Energy Star, but the builder can get some credit. Plus, if they're doing a traditional stick framed building, they can save some money on their framing package, which is never a bad thing. Okay, starting off here with our complete thermal enclosure system, we'll talk about high performance insulation. So critical to note that when we talk about high performance insulation, the program is not specifying any one particular product. It doesn't require us to install any type of insulation product. You can use any insulation products that are allowable by the building code. So fiberglass, whether it's blown or bat-based fiberglass, is totally fine. Cellulose, whether it's blown or bat-based cellulose, totally fine. Rock wool or mineral wool, totally fine. Spray foam, totally fine. It's all about how it's installed, and is it at least sufficient to meet the 2009 IECC if we look at the whole building put together. So again, 2009 IECC levels, these are looking at equivalent U factors, which are a little bit tricky in order to tease out what that really means. But here we go. If we take a look at, it's like I say, it's a little bit tricky, to look at this on a U factor basis. It's a lot easier to look at it at R values. But I know it off the top of my head, so I'm just going to go ahead and riff on this. The 2009 IECC required 0.35 U factor windows. It required ceiling insulation that was an R38 in climate zone 5. And then, wall framing, we were at R20 or 13 plus 5 for our frame floor insulation. It was an R30, and the basement wall insulation was either an R13 cavity or an R10 continuous. So these are the equivalent U values. So again, the assemble U value is take the whole building assembly. So if it's an above grade wall, you've got siding on the outside, you've got an airspace, you've got sheathing with maybe tieback on it, and then you've got a framed wall system that's maybe 25% wood and then 75% cavity insulation, and then you've got drywall on the inside. There's a way to do an average R value of all that and then convert that to a U factor. That's some nerdy building science that we won't necessarily go into great detail here, but that's how this equivalent U factor is calculated. But in essence, the 2009 IECC, it's a good, solid, insulated building. It's not anything totally revolutionary. In terms of how this equation might work in terms of documenting compliance with the 2009 IECC, we'll see here that on the right-hand side, this is our code reference value, and then here's the as-built home. And this is one that's built to the Michigan Energy Code, the 2015 Michigan Energy Code. So basically, if you just follow the prescriptive requirements of the Michigan Energy Code, you would end up with a UA calculation for the home, which is 245. We need to be less than the 2009 IECC, which is about a 251. So in this instance, we are better by about 2-3% than that 2009 IECC reference home. So that's a good sort of signpost for you to follow. let me just go ahead and follow the prescriptive values from the Michigan Energy Code, and I'll be good enough for Energy Star compliance. And you'll notice that those savings really come from Windows. So Windows and their requirement got a little bit better from 2009 era to the 2015 era. And I would say most home builders would probably agree that nowadays getting window values that are 0.32 or better, that's just every window basically. Window manufacturers tend to sort of up their game in response to building codes. And so, there's a lot of savings to be gleaned in Windows specifically when you go ahead and do this UA calculation. So if you're going to do version 3.2, which points to the 2021 IUCC, again, we're looking at assembly U factors. That's kind of tricky in order to understand if you're looking at it, but like specifically we'll call out, the ceiling, R value was required prescriptively to be an R60 prescriptive. The walls were required to be R20 plus 5 continuous or R13 plus 10. The windows are, a 0.30. So all of a sudden we've got more of a steep hill to climb. If we just build to the, we would have to really up our game in order to be compliant with this. So one way that you might go about it would be having walls that maybe aren't quite as good, but in windows that aren't quite as good. But if we make up a little bit on the roof, and then that's enough in this example to be just a little bit better than the 2021 IUCC. But again, you're having to expend a little bit more energy, a little bit more money in upping your game in terms of your wall system, your roof system. Things like that, are going to be, better insulated overall. So kind of tricky to look at this in terms of U factors. I think it's a little bit easier in terms of R values. We'll take that back for a future presentation. In terms of version 3.3, which is equivalent to version 3.2 if you're pursuing the tax credit, basically you're allowed to have they changed it from UA to total conductance or thermal conductance rather. Same idea, a little bit different insofar as you're calculating slab conductance a little bit different. So let's just call it a UA for the sake of argument, because that's essentially how it functions. But you're allowed to be 115% of the reference or prescriptive total thermal conductance. So as a result, if we go back to that same example, if we're comparing ourselves to the 2024 code, you'll notice that the 2024 code got a little bit tighter in terms of windows. It got a little bit looser in terms of requirements for above grade walls. Or sorry, not for above grade walls, but rather for roofs. But you'll notice here that we're above the UA for the 2024, but that's okay because you're allowed to be actually 115% of that. So we could go ahead and say, well, maybe we'll take that continuous insulation off those above grade walls and see how we do. And so if you're going to pursue the tax credit, I would recommend the 2024 route using version 3.3 because it does give a little bit more flexibility. Okay, so that's talking about how much insulation. Now, regardless of how much you put in, we got to make sure that we're installing it properly. So Energy Star refers to the ResNet insulation grading protocols, which many of you have probably heard of before. Grade 1 insulation is essentially, that's the best. That's essentially installing insulation per manufacturer's specifications. You're installing it in a way that minimizes compression as well as incomplete fill of the insulation. We really don't have gaps. There's essentially very little where you can see the sheathing to basically none at all. And again, the insulation is fully filling the cavity, side to side, front to back, top to bottom. with minimal compression or incomplete fill. Grade 2 allows for some additional defects, but overall, we really don't have substantially voided insulation where you can see the sheathing, as well as the surface area of the insulated cavity overall has very little compression. So I'll say, in my experience, if you're going to use a batt product, as many builders do, because they are economical, you really have to work with your installers to get to this grade 1 level, because that's what's required for Energy Star. So the challenge with batt products is that, you know, they are sort of 3D polygons of fluffy stuff. They have to be cut to fit, and then they have to be, you know, installed in the cavity around any obstacles like wires or framing members or plumbing. And yet they have to fill sort of homogenously. That's tough to do. You know, it's tough to, you know, crimp the insulation so it fully fills the cavity without major compression or gaps. It can be done. Any product can be installed at grade 1. It just becomes more tricky when you're using a fiberglass type batt type of product, or really any batt type of product. It becomes more difficult to achieve grade 1. Not impossible. You have to work with your installers. Grade 2 is allowed if we have continuous insulation on the outside of the home. Grade 3, which includes much more substantial gaps or voids or significant compression, grade 3 is not permitted in Energy Star. Grade 1, again, we're looking over on the far top left at a grade 1 installation of net and blown fiberglass. And what I really like about net and blown fiberglass is, man, it's a lot easier to get it at a grade 1. Why? Because we're stapling up a netting to the cavity, and it's allowing us to basically densely pack that cavity all the way full, and we can kind of see that it's nice and pillow tight. And it's a lot easier to get grade 1. It's a lot easier to work that blown insulation around wires, plumbing, framing members, other obstacles in the wall system or in a flooring system. Grade 2, we're looking there in the center at some fiberglass batts that are, you know, maybe generously grade 2. You know, why is it grade 2? Well, it looks like the cavity is pretty much all the way full, but the challenge is that we do see some compression and incomplete fill of some of the cavity. It's tough to get batts perfect in this type of horizontal assembly, in my experience. And then we see grade 3. This appears to be some kind of like a staircase, and so, you know, the framing for whatever the structural loads were tighter. It looks like that's more like 12 inches on center instead of 16 inches on center. And the installer, instead of splicing the insulation vertically in order to get 12-inch wide batts, they essentially just took the 16-inch wide batts and sort of stuffed them in. And the problem with that is, in order to fit that in, it has to be significantly compressed in some areas. We can also see some voids. So that would be an example of grade 3 insulation not allowed for Energy Star. Again, grade 2 is allowed where you have, for above grade walls, if you have continuous insulation on the outside of the home. It is also allowed to have grade 2 insulation for frame floors over things like garages or frame floors over a crawl space. But you have to essentially compress the insulation up against the surface that you're intending to insulate, such as the subfloor, so that essentially compression is allowed, but you still cannot have major gaps and voids and meet this requirement. Okay, moving on here. High performance insulation, or sorry, excuse me, fenestration rather. High performance fenestration. So we're talking about windows and doors and skylights. Again, windows and doors are an element of consideration in the total building UA calculation, or if you're using version 3.3, the thermal conductance calculation. So you don't have to install Energy Star windows in order to participate in Energy Star. And there isn't a specific minimum window value that is required ultimately, unless you are in a hot climate like climate zone 1 through 3 or parts of climate zone 4, then there are specific window SHGC requirements. But if you're just doing version 3.1, I mean, essentially you have to, you're going to make up a lot of ground with windows today. Because if you just go and buy a standard window off the shelf at Home Depot, it's going to be somewhere around 0.30 U factor at this point. And the version, of 3.1 that points to 2009 IUCC, the windows were close to 15% worse than that at 0.35. So you're picking up savings just by essentially buying modern building products when it comes to windows. If you're getting to version 3.2 and even 3.3, the savings become a little bit less because those window requirements prescriptively are getting closer to what is on the shelf today. So Energy Star does have a window and door labeling program. You can specify and install Energy Star labeled fenestration. And there are different criteria depending on where the windows are to be installed. We here in Michigan, we're in the northern criteria. So it is not required to install Energy Star windows and doors in Energy Star homes. And some people get that wrong. They go, well, the builder did everything else that they were supposed to, but they didn't install Energy Star windows. I guess they can't be an Energy Star home. That is a factual inaccuracy that many people get wrong about Energy Star. Basically, you don't have to install just about any Energy Star products in an Energy Star home to earn the Energy Star label for the home. I know it's crazy to think of, but that is true. But again, what the value of the Energy Star window and door label is that it gives consumers, I think, and builders a better option to just point to and just to say, I want to put this element into my building because I know that it's going to be energy efficient and it will probably help me comply with Energy Star Homes program. So there is value to the Energy Star windows and doors program. I put in Energy Star windows in my own home recently. I think there's value to the program without a doubt, but it is not required for Energy Star certified homes. Reduced thermal bridging. So this is talking about the framing that goes into our buildings. The way that thermal bridging works, if you're not a building scientist, is that our buildings are made of dissimilar materials. And when I say that, I mean that, almost never do we have buildings that are built out of one homogeneous material that is the complete wall system, for example. Even if it were a cinder block house, even a cinder block house has the concrete ribs of the cinder block, and then they have air spaces in between those cinder blocks, and so it's not actually all the way homogeneous. In modern typical construction, we use wood framing, sometimes steel framing. Obviously, there are alternate systems like insulated concrete forms and SIP panels, and we'll talk about those here in a second. But just the typical house that's built in America is built stick framed. Why? Well, because it's cost effective and a lot of people know how to build that way. So the way that thermal bridging works is that, well, what's more insulative, insulation or wood? Well, it's called insulation for a reason, because it insulates. Wood does insulate to a degree, but substantially less than insulation. So most common wood insulates at about R1 per inch. And that's pretty similar to like drywall. It's pretty similar to siding. Let's just think of all that stuff about R1 per inch. Insulation is somewhere typically between about an R3 to an R5 per inch. So we're getting more bang for our buck in terms of insulation value per space when we have insulation. So the place where there is not insulation in our building enclosure, that's what's considered to be thermal bridging. It's a path of least resistance. The way the physics works is that heat flows from hot to cold. So in our homes, we like to keep them at about 70 degrees in the summer, or sorry, in the winter time when it's cold. And if it's 20 degrees outside, that means there's a temperature difference, and that's what causes there to be the heat loss off of our buildings. So, and again, the heat isn't smart. It doesn't know that we want it to be blocked by insulation. It's going to go for the path of least resistance. And so when you just have essentially wood framing without any continuous insulation on the outside, that's what we refer to as a form of thermal bridging in buildings. And so ideally, less framing in a wall system and more insulation is better. And that's the idea with reduced thermal bridging. So we can see, two images here. One that shows a home that just has conventional framing with an insulated cavity. Why is it that we see this? Well, because the warm colors, the yellow, that's heat loss. And the cool colors, that means that there's not very much heat loss occurring here. So the house is warm. We can see that through the windows. And so it's probably cold outside. And so we can starkly see the heat being lost through those framing members faster than it's being lost through the insulated cavity. And so the image below is the same deal, but that's a home that's wrapped in continuous insulation on the outside. And so overall, while we can see a little bit of definition still with the framing members, it's a lot less overall. That's the value of adding continuous insulation, is that it stops heat flow across the complete exterior of the home, both the framing as well as the cavity. And so there's some value to doing continuous insulation for that reason. But otherwise, if we take the above image, there's value in just reducing our framing and adding more space where insulation can be present. So again, as of revision 14 of the program, reduced thermal bridging is no longer mandatory. It used to be that you had to choose an option for implementing reduced thermal bridging, and it was a mandatory element of Energy Star. That's no longer the case anymore. So now there's a way to account for these reduced thermal bridging practices, but they aren't necessary. They're not mandatory. So some of the things that can be assessed is, just the on-center spacing and framing for walls, as well as insulated headers, insulated corners, wall interior to exterior wall intersections, etc. Those can be assessed. For ceilings, the insulation at the edge of the ceiling where it meets the above grade walls, that's what we call the top plate. You can assess whether or not you've got a raised heel truss that allows for a full depth installation, or whether or not you're going to have compression at that spot. That's now something that's supposed to be accounted for more granularly in HERS model. And then insulation platforms. So let's imagine that you have HVAC up in an attic. There will typically be a raised platform, and you're supposed to insulate underneath it completely. But if not, there's a way to account for it in the energy model if we have reduced insulation at those walkways or platforms. Attic hatches. Again, ideally, we would have attic hatches that are the exact same R value as the rest of the attic insulation. If that's not the case, we can assess them separately. Same thing for whole house fan covers or pull down stairs covers. And I apologize, for some reason, the presentation just sort of glitched here. Let's see if we can just get it to respond normally. There we go. All right. Phew. All right. Going back to above grade walls, I'd say that's one of the bigger areas where we can make improvements in reducing thermal bridging through wall system framing. So again, there's the option to consider standard spacing on the walls, which would be 16-inch on center, or a more advanced spacing like 24 inches on center. You see, between comparing these two images, when you move to 24 inches on center, now you have more space for insulation. You have less framing members. That's a good thing because now we have more insulation instead of less. The other thing that's good about it is that the builder can save some money because now instead of having to have as many framing members, they can cut it down by about a third. Insulated headers. So we can see in the above image here, between the two pieces of dimensional lumber, there's a rip of foam board that's about an inch. And so instead of having essentially, 3 framing members ganged up, we have foam board in the center that insulates that header. We see here interior to exterior wall partitions and a ladder T section here, where basically that allows insulation to go between that interior to exterior wall area. Minimize framing around windows and doors. So Energy Star recommends a single king and a single jack stud, basically adjacent to each window and door instead of big giant gangs of framing members. As well as minimize cripples underneath windows and doors. And then finally, insulated corners. So basically a way to get at the corner of exterior walls to be able to get insulation in behind that corner so that we have a more complete insulation system. These are all elements of advanced framing in wall systems that can be taken advantage of in Energy Star, but are no longer absolute requirements. Insulating slabs, again, no longer a mandatory requirement, but something that can be taken advantage of. And there's ways to model different configurations that are maybe incomplete elements of slab insulation. But again, a best practice, especially in a cold climate, otherwise people have very cold floors and a lot of heat loss if you do not insulate slabs that are on grade in cold climates. Moving on in Energy Star, beyond how much insulation you install, beyond installing it in a quality fashion, and beyond installing more of it, because ideally we would have continuous insulation or some form of reduced thermal bridging. Let's get to making the home more airtight. So we can do that with fully aligned air barriers. This home has a product called Henry Blueskin, which is a peel and stick membrane that is used both as the air tightness layer as well as the weather resistive barrier on the home. And that can help to make all the wall systems very airtight. There are 2 major sections that deal with air barrier and air sealing requirements, fully aligned air barriers, section 2, as well as air sealing details. What you note is that a lot of these things are just kind of the same stuff that's in energy code. So it's not really a major variation from what people should already be expected to be doing if you're following the energy code. Pretty straightforward stuff in terms of air sealing and air barriers. What's new to the program is that there's now, as of revision 14, mandatory air tightness provisions. So before, there actually wasn't a hard limit on how much a home could leak to be Energy Star. Now there is. If you're following version 3.1, you have to be 4.5 ACH 50 or tighter. And prescriptively here in Michigan, we're at 4 ACH 50. If you go a performance method, you can be a little bit above that potentially and still meet code. But essentially, we should be good to go here in Michigan to meet this 4.5 ACH 50. It's not super, super tight. Version 3.2 and version 3.3, again, a little bit more grace. And then for smaller or attached homes, you can actually have a CFM per shell area leakage allowance, which is even a little bit more loose. The 0.3 CFM 50 per shell area is equivalent closer to a 5 to 7 ACH 50. So the idea here is that smaller homes, air leakage tends to be less critical ultimately in terms of overall energy performance. So there is some trade-off there. Um, air barriers need to be aligned at ceilings, walls, and floors. Again, I would dive in specific to the checklist in order to really kind of dive into the devil and the details on this. A big thing with ceiling insulation is that basically, we have to make sure that we have soffit baffles so that when we blow in attic insulation, that it's not going to get wind washed away. So that is a critical element. Behind stairs, especially in multifamily buildings, behind knee walls, attic knee walls, as well as behind tubs or showers that are on exterior walls. These all require having complete air barriers. And I'm not sure what's going on here with my computer. It is, for whatever reason, having a problem. Okay, and floors. So floor insulation needs you either need to have insulation in contact with the top side, so the subfloor, or you need to have it in contact with the drywall below, and that allows it to be a complete air barrier system allowable by the program. And I'm just going to go ahead and stop my share here and see if I can reopen this presentation, because this is obviously going to be extremely tedious if it continues like this. Well, folks, unfortunately, This is not necessarily the best thing I can say, but the presentation really is having a hard time loading on my computer at the time, and we are at our time limit. So unfortunately, I'm probably just going to have to call it here. I will work out with DTE and Consumers about any modifications that need to be done to this recorded presentation to make sure that the recorded version includes all the slides on air sealing details. Apologize for this, but we will work it out and get a complete version posted for your attention at a later date. Thanks everybody for your attention. I apologize for the technical difficulties, but we'll make sure to get this addressed with the recorded version.